Alright, let's go ahead and do a little bit of a review of the three types of symmetry we'll be talking about. One's over the y-axis, one about the origin, and then one about the x-axis. So in class, I think we said we're symmetric with the y-axis if we can do like a hot dog fold. So if I fold this function inward on itself, it's kind of like a hot dog fold, line up with itself. So that would be a characteristic of a symmetric with the y-axis, or later we'll call it an even function. So another characteristic of an even function is both xy and negative xy are on the graph. So to kind of point that out here with a concrete example, here's 2, 4, there's your x and y, and then negative 2, 4, there's your negative x and your negative y. So that would be a characteristic of even graph. And then we could do one more. 3 and 9 and negative 3 and 9 also appear on the graph. So the test that we'll do is we'll plug in negative x and see if the equation is the same. And we're going to end up doing that later with functions, testing if they're even or odd. And our function here is y equals x squared. So we'll plug negative x in. Negative x squared is negative x times negative x. The negatives cancel and we're left with x squared. Because these are the same as the original function, and when we plug negative x in, they're the same, that's an indication, that's our test for it's symmetric with the y-axis, or we call it an even graph. Okay, let's go ahead and look at symmetric with the origin. So here, if we spin this all the way around at 180 degrees, it's going to line up with itself. Or we spin this branch all the way this way, it's going to line up with itself. Okay. So symmetric with the origin, xy and negative xy are going to be on the graph, and that's what we're going to see here. So I'm going to find 1 and 1's on the graph, and also negative 1 and 1 is on the graph. So there's your xy and negative x, negative y. Also 2 8's on the graph, and negative 2, negative 8. Oops, I need to put a negative on there. Let's add that in right here. And a negative, negative 8. Okay. To test, we're going to plug negative x in again, kind of like the last time, and then we're going to see if we get the opposite. Opposite being opposite signs. So instead of getting y equals x cubed, we should get y is equal to negative x cubed. So let's go ahead and plug that in. Plug in negative x. So it'll be negative x times negative x times negative x because of that x cubed. And we get negative x cubed. These are opposites, so that would be indication that we are symmetric with the origin. Now the last one we will look at is, it's not going to be a function, but it's going to be symmetric with the x-axis. So what I'm going to look for is x, y, and x negative y are on the graph. And this one, you see, if we fold it in on itself, kind of like hamburger style, it's going to line up with itself. So that's characteristic of symmetric with the x-axis. So what I'm going to find here is I'm going to find 4, 2, and 4, negative 2 are both on the graph. So that fits that xy and x negative y. And I'll also find 9, 3, and 9, negative 3 as another pair of points. So most of the time, our function is going to be solved for y, or it's going to say f of x equals. Now here, if it doesn't say y equals, like in this one, I think it's going to have a plus or minus. It's going to say x equals, and then we'll have to solve and we'll get a plus or minus. So how we do this is, if there is a plus or minus, our chances are that it's going to be symmetric with the x-axis. So if we take the equation x equals y squared, if we square root both sides, we're going to get plus and minus square root of x is equal to y. And because we have that, if I plug in values in for the x, I'm going to get two outputs. X is your input, y is your output. So if I plug in x is 4, square root of 4 is 2, and then we get plus and minus 2 as my two outputs. Okay, so that's odd, even, and symmetric with the x-axis. We'll see them again, and it just takes a bit of practice.